Lake Tahoe looks fine right now. Boats are launching, docks are in the water, marinas are celebrating, but the mountains above it are telling a very different story. The snowpack feeding this lake just posted the second lowest April reading in 76 years of records. Some measuring stations found no snow at all. The lake you see is not the lake you think you're seeing. And here's why. Right now, the gauge at Tahoe City is reading 8.5 feet of water height, turned into elevation. That puts Lake Tahoe at 6,228.58 feet above sea level. For comparison, the legal top set by federal court ruling in 1935 is 6,229.1. So, the largest mountain lake in North America is sitting roughly 6 inches below its legal ceiling as we speak. Water is actively leaving the basin. The Truckee River at Tahoe City is flowing at 292 cubic feet per second, pushed through the 17 gates of the Lake Tahoe Dam. For a casual viewer, that is a picture of plenty. For the people who run this system, it is something much stranger. Because 200 miles of Sierra Nevada mountain country behind this lake is almost bare. The April 1st snowpack survey came in 3 weeks ago. Statewide snowpack, 18% of normal. Second lowest since measurements began in 1950. The only year worse was 2015, a year that sparked emergency drought warnings and statewide water limits. Zoom in to the Tahoe Basin and the picture gets worse. The northern Sierra region is running at 6% of average. The Lake Tahoe Basin itself is at 13% of normal. At Phillips Station, where workers have hand-measured snow every April for decades, they found no measurable snow at all this year. The meadow was green. So this is the mystery we have to solve. The lake is almost full. The mountains feeding the lake are almost empty. Both things are true at the same time. How is this even possible? The answer is hiding in the word rainfall. Here is what most people get wrong about the Sierra Nevada. They think snowpack and rainfall are the same measurement. They are not. Rainfall this water year in the northern Sierra is actually near normal. The 8-station index, which has tracked storms since the 1920s, is reading 47.3 inches through April. That is 102% of average. The storms came, the water arrived, it just did not arrive as snow. This is the shift that is quietly rewriting how water moves in California. Every major storm that pushed through the Sierra this winter came in warmer than storms used to be. Freezing levels, the height at which rain turns into snow inside a cloud, rode higher than they should have. On the big ocean storms in November, December, and February, the freezing level often climbed above 7,000 feet. Tahoe sits at 6,223 feet. Do the math. The storm cloud above the basin was making rain where it used to make snow. And rain acts very differently from snow. Snow is nature's water tank. It falls, it freezes, it stacks, and it waits. It lets go slowly over 3 or 4 months as spring warms up, trickling down into streams, feeding the lake on nature's timetable. A healthy Sierra snowpack is basically a second water tank sitting 10,000 feet above Sacramento. Rain does none of that. Rain falls, hits the ground, and runs right away. So, when an ocean storm dumps water on the Tahoe Basin as rain instead of snow, that water does not park itself up high for spring. It runs down 63 streams, pours into the lake within hours, and pushes the level up. That is exactly what happened this year. The lake filled fast because the mountains could not hold their usual supply. And then February happened. Between February 15th and 20th, the Central Sierra got hit by what is now being called the superstorm cycle. Palisades, Tahoe recorded 9.5 feet of snow in 5 days, the heaviest 5-day total at that resort since 1970. Snowfall rates hit 4 inches per hour. Winds topped 90 miles per hour. For about a week, it really looked like the winter was turning around. Then it did not, because right behind that cold storm came a warm ocean storm. From February 21st through 26th, the freezing level climbed back above 7,000 feet, and a week of steady rain fell on the fresh snowpack. The snow that had just stacked up melted where it sat. It did not last to spring. It went straight to the lake as melt and runoff, and between late January and early March, Lake Tahoe rose roughly 0.8 of a foot. That is about 31 billion gallons of water added in 6 weeks. The lake was filling. The mountain was draining. Same storm system. And then March finished the job. March 2026 is now the warmest and driest March in California's recorded history. The lower 48 states as a whole recorded a March temperature 9.35 degrees Fahrenheit above the 20th century average. 1,432 counties set records for their warmest March day ever. In the Sierra Nevada, the record heat acted like a blowtorch on what little snow was left. The April 1st snowpack survey was not just low. It was the ending point of a snowpack that had already melted. Peak snow water amount in the Sierra arrived around February 24th this year. That is 5 weeks earlier than the usual peak of April 1st. Across the broader western United States, peak snowpack timing is arriving 21 to 34 days earlier than normal. This is what we are dealing with right now. A lake that is almost full because the water that should be waiting in the mountains has already been delivered. The lake is not thriving. The lake is holding a receipt. So why is Tahoe uniquely set up to tell this story? The answer is in the land itself. Lake Tahoe is not a normal lake. It is a fault block basin, a slab of the Earth's crust that dropped straight down between two parallel cracks in the ground. The Sierra Nevada rose on one side, the Carson Range rose on the other, and the land in between sank. That sinking happened roughly 2 to 5 million years ago, part of the broader stretching of the Earth that built the Basin and Range region. The basin that resulted has an unusual shape. It collects water from 63 streams pouring off 2 mountain ranges. But it releases water through exactly one outlet, the Truckee River, which leaves the lake at its northwest corner. That outlet is controlled by the Lake Tahoe Dam, an 18-foot-tall concrete wall built in 1913 with 17 hand-operated gates. The most water the dam can release is roughly 2,100 cubic feet per second. That matters hugely. Because Tahoe has one drain, and that drain has a speed limit, the lake acts like a massive bathtub with a small outflow pipe. Water comes in fast, water goes out slow. And the whole working range of the lake, between its natural edge and its legal ceiling, is only 6.1 vertical feet. Here is the math that makes all of this touchy. Lake Tahoe's surface area is 191 square miles. That comes out to 122,240 acres. So raising the lake one single foot takes about 39.8 billion gallons of water. The whole working range between the edge and the legal top is 744,600 acre-feet. 243 billion gallons. That is not a lot of room. A single ocean storm can move the lake 6 inches in a week, which is exactly what has been happening this winter. And this is where the past stops being past and starts being warning. The event everyone in the basin still thinks about is 1997. On New Year's Day that year, a warm ocean storm hit the Sierra, dumped rain on a deep snowpack, and the combined runoff pushed Lake Tahoe above its legal top. The Truckee River peaked at nearly 12,000 cubic feet per second through downtown Reno. Water stood 4 feet deep in Reno's streets. $700 million in damage. The lesson from 1997 is not just about flood control. It is about how warm storms mix with snow. Rain on snow multiplies runoff. Rain instead of snow front-loads runoff. Either way, the snowpack that used to slow the Sierra's water release is losing that job. And that is still the problem we are dealing with today. 2 decades later, in the ocean storms of early 2017, Tahoe rose 2.8 feet in 6 weeks, about 110 billion gallons of water. Dam gates opened to their widest position in 18 years. That was a controlled event inside the legal range. But the trend line was already clear. Storms were getting warmer. Snow-to-rain ratios were shifting. The mountain was losing its ability to store. What we are watching now is that trend sped up and squeezed together. The 2025 to 2026 water year did not produce a single dramatic Tahoe flood. What it produced was something scientists have been warning about for 30 years, finally showing up in full. A near normal amount of water, delivered on the wrong schedule, in the wrong form, at the wrong height. There is a single number that captures the whole story. In 1910, snow made up roughly 50% of all Sierra Nevada rainfall and snowfall combined. Today, it makes up 30 to 40%. The Sierra is slowly becoming a rain range instead of a snow range, and Lake Tahoe, the largest mountain lake in North America, is the most visible scoreboard for that shift. So what happens next? In the short term, things look stable. The lake is full. The water agencies downstream expect to run through summer on stored water without touching drought reserves. The federal water chief is calling for a normal water delivery year for users below the dam. But the words normal and stable are doing heavy lifting in those statements. What actually holds them up is leftover water from the wet years of 2023, 2024, and 2025. Lake Tahoe is near full because past winters were actually wet. Not because this winter was. Take out that leftover water, and this year's Sierra Nevada snowpack would not feed the region. The snow that would normally be melting into the basin in June and July this year is already gone. The water flowing into the lake will slow early. Streams that should still be roaring with meltwater in May will drop to trickles by late June. Fire crews across California and Nevada are already getting ready for an early, severe, long wildfire season because plants are drying out 6 weeks ahead of schedule. And then the real test arrives in November. If water year 2027 opens with a dry October and a warm November, the bathtub drains. The leftover supply disappears. The stored reserves that are quietly propping up this year start getting pulled down with nothing replacing them. A single dry winter on top of this would drop Lake Tahoe below its natural edge for the first time since the 2021 to 2022 drought. And at that point, the Truckee River stops flowing at all. The lake is not the crisis. The lake is the warning sign. The crisis is a Sierra Nevada that no longer works as a water tank, and a water system built around the idea that it would. Here is what to watch for over the next 6 months. First, how fast the lake drops between June and October. That is your real measurement of whether this year's rain was enough. Second, the opening storms of November and December. Any warm, rain-heavy November ocean storm would prove this pattern is speeding up. Third, the April 2027 Snowpack survey. If it comes in below this year's number, the Sierra Nevada will have posted 2 low snow years in a row, and California's water system will be in territory it has never worked in before. Lake Tahoe is trying to tell you something. It is not showing you plenty. It is showing you the last of what the mountain had stored, draining downhill while the snowpack that should be replacing it posted the second lowest reading in modern history. The lake looks fine. The lake is not the story. If you want to follow how this unfolds, subscribe. I cover these water systems every week, and the next chapter of this one writes itself in about 8 months.